Good afternoon, students. The subject we are treating today is physics. My name is Alibiusu Adibola. The topic is derivation of escape velocity of the satellite and the velocity at which the satellite moves in a circular motion. The behavior objective is that students should be able to 1. Define escape velocity. 2. Derive expression for escape velocity v equals to square root of 2gr. You should be able to derive expression for velocity at which the satellite moves around, which is v equals to square root of gr. Let's start with the definition of escape velocity. Escape velocity is the minimum velocity required for an object, e.g. satellite or rocket, to just escape or leave the gravitational influence or field of an astronomical body, e.g. Earth. The satellite are being put in place. When it got weakened, the magnetic force got weakened, it gets loose and escape away into the space. We want to see the derivation, the formula that needs to apply in solving this problem. Today we are going to deal with the derivation. Next class, we'll start solving problem on escape velocity and also the velocity at which the satellite moves around the Earth. And let's start with derivation. We have F subscript G to be equals to G M subscript E M over R subscript E squared, and at the same time is equals to mg, because we deal with gravity. Force equals to ma, but since we are dealing with gravitational force, we are going to make use of F equals to mg. From there, m cancel m, mass of the object. Fg, let's write the meaning of each of them. Fg equals gravitational force. Gravitational force. Let's take notes. G equals gravitational constants. Gravitational constants. Gravitational constants. M subscript E stand for mass of the Earth. Mass of the Earth, while M equals mass of the objects. Mass of the objects. Mass of the Earth we are going to put into consideration because revolving around, and also the satellite is the mass of the object stand for the satellite. Now we are going to relate the two together, as we have said before, that F equals to G M E M over R E squared equals to mg. M cancel M. After the M cancel out, we have G M E over R E squared equals to G. From here you cross multiply. We have G M subscript E equal to G R E squared. Take note. Let's take this one to be our equation 1. Anytime You see GME, you replace it with GRE squared. Now, you notice that the earth revolve round, and when there is motion, there is kinetic energy. We will now go back to the formula for work. We are trying to derive the escape velocity at which satellite moves away from where it's being placed. Work equals force times radius of the earth. You replace your force with G M over RE squared times radius of the earth. And one of the radius cancel this radius. You now have your work to be GMEN over RE. Take note, let it be at the back of your mind that work is gravitational constant multiplied by mass of the earth multiplied by mass of the object over RE. And you have to equate it to the kinetic energy, because when object is moving, work is being done and kinetic energy is taking place. Half mve squared. You relate the two together. From there, the mass cancel mass. We are left with G M E over R sub E equals to V E squared over 2. Here we cross multiply. When you cross multiply, you have V E squared RE equals 2GME. You divide both sides by RE. Divide both sides by RE. You have V sub E squared equals GME over 2GME over RE. Over RE, you find the square roots of both sides, and the two cancel the square root. You are left with VE. You are left with VE equals square root of 2G ME over RE. You replace GME with GRE squared, as I have said before, as I told you before. 2 GME GRE squared. GRE squared over RE. RE cancel one of the RE. Now have VE equals square root of 2GRE. This is the formula to use to get the velocity of escape. the formula to use to get the velocity of SP. VE equals square root of 2 GRE. And G is isolated to gravity, R is the radius of the Earth. The third aspect is how to derive the expression for the velocity at which the satellite is moving. Now, from there, we have the formula for the centripetal force, which is equals mv squared over r. We are going to relate it with gravitational force because it's the force that keeps the object moving, not to skip away from the circular motion. Now, mv squared over re is the centripetal force, which is equals to GMEL over RE squared. From here, M cancel M, RE cancel one of the RE. We are left with V squared equals GME over RE. This expression after the division. From there, we proceed to square root both sides. Find the square root of both sides, the two cancel the square root. So I left with V equals square root of G M E over R E. I told you before previously that you will replace the GM with GRE squared. GRE squared divided by RE divided by RE. Now have RE cancel one of the RE. You are left with V equals square root of GRE. This is the velocity at which the satellite moves around a circle, around the Earth, first spherical form. Now, when the satellite loses the gravitational force due to the weakening in the electronics inside the satellite, it escapes to the surface, to the space. That's the velocity. When you have to look for the velocity of the satellite, make use of V equals to square root of GRE. This is the end of the class. Next class, we are into solving problems on the escape velocity and also the velocity of the satellite. Thank you and have a nice day.